Welcome to Project Atlas. My name's Andy Ramgobin and I am the CEO and co-founder of CodeZero. So today we're going to be delivering a demo on Atlas, which is our proprietary sovereign LLM agentic platform that is designed specifically for a use case of liquid immersion cooling sales and systems engineer specialists. And as always, you can see the VS Code space is how we start all of the videos. And this is me just going through one particular file which tracks the progress of the entire project. Now you're looking at Prometheus and Grafana, and it's the NVIDIA GPU exporter dashboard, not DCGM like we do for all of our immersion deployments. That is because this is a GB10 SOC device, and so we're monitoring GPU performance at the inference layer and not at the data center fabric layer. And as always, we have node exporter or plugged into Grafana that allows us to do all of the observability from a hardware perspective. So we've branded OpenWebUI, so it looks a little bit more like CodeZero. So we've taken our CodeZero colors and brand, and we've been able to do some nice CSS injection to make it look a little bit more like CodeZero front end. And a lot of people will be used to something like ChatGPT's front end, well, OpenWebUI. We're using the free version, the open source version, but there is a paid for version that you can use. And ultimately, OpenWebUI is just a UI for us. Llama is just serving the model because we don't need production grade using something like VLLM at this point. And we're using an SLM, Llama 3.1, 8 billion parameter model. So I'm going to flick through this really quickly. This is us asking Atlas a question around, if the inlet temperature into a GRC Duo is X, then please give me some thermal details in terms of the outlet, in terms of the delta T. Give me a server design for a specific workload of a specific size, and then give me benchmarks for a workload that's been run in immersion. Now, this is all our own data, our own designs, and this all sits in our own immersion app, again, which is proprietary, designed by us, hosted in AWS, called Poseidon. You can see, we're not going to show you all of the other dashboards in Poseidon, but you can see some of the dashboards, which is where this information is being pulled from. Now, it doesn't connect directly to Poseidon. We've stored the data in machine readable code, and Llama is able to use the model in OpenWebUI via an API that we built and an orchestrator, which is an agentic control plane that we built, and it's able to access that information. So that was one of the first capabilities. Now we're going to start on our first agent, the quote agent. Within less than 5 seconds, even if we spell the prompt wrong, you can see I've put quote without an E on one of those quote requests. You can see 2 different quotes that are coming in with the pricing from GRC and the dielectric fluid being included. Another prompt we can run is generate a proposal, and as you can see, we get a very nice, slick, fancy proposal generated into HTML, rendered, and we can export this to a PDF. This also pulls information from Poseidon and another document that I wrote personally around use cases, solution design, performance benefits, all of the kind of the good stuff. And so that is 2 agents that we've built in summary. And again, this is really, really quick. You can just generate a proposal or a quote in minutes, and it's all coming from validated sources, either us as CodeZero or GRC. So we're going to move on to the next agent, which is around environmental impact analysis. And this is something that I wanted to do last year. We measure a lot of the performance statistics and the tank PLC metrics from GRC. That means that we're able to have a really good understanding of what the server is doing when it's running a particular workload, how it's performing, and how the tank is performing. So what we wanted to do is build an agent capability that could take a specific server, in this case, an 8 GPU HGX server with B200s, some 2 large P-core Intel CPUs, calculate the power draw at 85% utilization. We know the thermals from the GRC Duo because we have those from Poseidon. And so we're able to calculate heat captured, inlet, outlet, convert that from kilowatt hours to megajoules. And then we're able to say, well, how much, based on the EWT, how much spare capacity in terms of power and servers has the rack got? And then we're able to then start looking at breaking this down and looking at how much heat can be recovered based on scope 1 in terms of carbon offset, and we are able to give you a carbon credit value. Now, this is all estimated. The next agent, although it's not quite an agent, it's more like a control mechanism, is all around deployment of GRC racks, whether those are LTA, so liquid to air, or full immersion. So we have a set criteria that we have from GRC, from their site readiness checklist, and an ops manual that we pulled information from one of their big customers, and we're able to say, here's a specific situation to Atlas. Can you tell us whether this customer is ready for immersion? And you'll either get pass, fail, or blocked, and critical passes. Atlas will show you where you've passed, Atlas will show you where you've failed, and ultimately you can go back and look at those things. So if it's something like you've not reviewed the fluid SDS sheet from the dielectric fluid manufacturer, then you've got to do that because you have to understand things like flashpoints. So this is a really detailed way of being able to gate yes or no for a customer. Can you deploy immersion? And this is something that we know that we come across a lot of the times. People get interested in immersion, and then when we start speaking to them, we find that actually they don't have the right site requirements. So we're going to look at the very last of our agent stroke control mechanisms, and this is where we've built a safety and immersion operations manual. So a large amount of this content is coming from Viridian's DC operational manual. They are a customer of GRC's, and they've been running immersion at scale in production for a number of years, and they've probably got more experience in actually maintaining and managing immersion than most other people. So you'll see a whole different host of questions like thermal considerations, what cabling can we use, how do we manage spills in the data center or the data hall or on site, and all of this information is available. And it's really important to say at this point that there is no way that Atlas can fabricate or hallucinate data and give you incorrect information. The model has no free will because the amount of guardrails we've put in place, it can only answer and will only answer from a trusted source of information. And every single output that you see in Atlas has a cited source of information, so the user knows exactly where it's coming from. Now, of course, this is an MVP demo platform, and we can build more functionality into it. We can tweak things, we can improve things. You're seeing some RAG stuff here now around safety SDS sheets. It's retrieval augmented generation. And that's it. That's Atlas in a nutshell. Extremely powerful platform.